Crash course on model evaluation for business analytics. Introduction to business analytics models. Business analytics models are powerful tools used to analyze data and extract valuable insights for decision-making in various industries. These models leverage statistical and mathematical techniques to uncover patterns, relationships, and predictions from data. In this crash course, we will explore some of the commonly used business analytics models, including K-means clustering, linear regression, linear, logistic regression, LR, support vector machine, SVM, naive Bayes, NB, decision tree, DT, and time series forecasting, ARIMA. 1. K-means clustering. K-means clustering is an unsupervised learning algorithm that groups similar data points together based on their characteristics. It is commonly used for customer segmentation, market research, and image processing tasks. 2. Linear regression, linear. Linear regression is a supervised learning algorithm that establishes a linear relationship between the input variables and the target variable. It is used to predict continuous numeric values and understand the relationship between variables. 3. Logistic regression, LR. Logistic regression is a supervised learning algorithm used for binary classification problems. It estimates the probability of an event occurring based on the input variables and applies a logistic function to make predictions. 4. Support vector machine, SVM. Support vector machine is a supervised learning algorithm that separates data into different classes using a hyperplane. It is effective for both classification and regression tasks and is particularly useful when dealing with complex decision boundaries. 5. Naive Bayes, NB. Naive Bayes is a probabilistic classifier that calculates the probability of a data point belonging to a particular class based on the given features. It is widely used for text classification, spam filtering, and sentiment analysis. 6. Decision tree, DT. Decision tree is a supervised learning algorithm that uses a tree-like structure to make decisions based on the features of the data. It is intuitive and can handle both categorical and numerical data, making it suitable for various applications. 7. Time series forecasting, ARIMA. Time series forecasting involves analyzing and predicting future values based on historical patterns and trends in time-ordered data. The autoregressive integrated moving average, ARIMA, model is commonly used for time series forecasting. Model evaluation methods. Once the models are trained, it is crucial to evaluate their performance to ensure their effectiveness and reliability. Various model evaluation methods are used to assess the model's predictive power and their ability to generalize to new, unseen data. Here are some important evaluation techniques. 1. Confusion matrix, CM. The confusion matrix provides a comprehensive view of the model's performance by showing the number of true positives, true negatives, false positives, and false negatives. It is particularly useful for classification problems. 2. Accuracy. Accuracy measures the overall correctness of the model's predictions. It is calculated by dividing the number of correct predictions by the total number of predictions. 3. Precision. Precision measures the proportion of true positive predictions among all positive predictions. It focuses on the correctness of positive predictions. 4. Recall, sensitivity. Recall, also known as sensitivity or true positive rate, measures the proportion of true positive predictions among all actual positive instances. It focuses on capturing all positive instances. 5. F1 score. The F1 score is the harmonic mean of precision and recall. It provides a balanced evaluation metric that considers both precision and recall. 6. Receiver operating characteristic ROC curve. The ROC curve plots the true positive rate against the false positive rate at various classification thresholds. It helps assess the trade-off between sensitivity and specificity. 7. Area under the curve, AUC. The AUC is a metric that quantifies the overall performance of a classification model by calculating the area under the ROC curve. It provides a single value to compare different models. 8. Mean squared error, MSE. MSE is a metric commonly used for regression problems. It calculates the average of the squared differences between the predicted and actual values. 9. R squared, R2. R squared measures the proportion of the variance in the target variable that is predictable from the input variables. It ranges from 0 to 1, with higher values indicating better model fit. 10. Cross-validation. Cross-validation is a technique used to assess the model's performance on unseen data. It involves splitting the data into multiple subsets, training the model on some subsets, and evaluating it on the remaining subsets. 11. Overfitting and underfitting. Overfitting occurs when a model performs well in the training data but fails to generalize to new data. Underfitting, on the other hand, happens when the model is too simple to capture the underlying patterns in the data. Both scenarios should be avoided. 12. Model comparison. Model comparison involves evaluating multiple models using appropriate evaluation metrics and selecting the one that performs the best based on the specific problem and requirements. By employing these model evaluation techniques, analysts can assess the strengths and weaknesses of their models, make informed decisions, and improve the overall performance of their business analytics projects. Summarization. In this crash course, we explored the field of business analytics and its various models, including K-means clustering, linear regression, logistic regression, support vector machine, naive Bayes, decision tree, and time series forecasting. We also delved into model evaluation methods such as the confusion matrix, accuracy, precision, recall, F1 score, ROC/AUC curve, mean squared error, R squared, cross-validation, and the concepts of overfitting and underfitting. These evaluation techniques allow analysts to measure the performance and effectiveness of their models, enabling them to make informed decisions and optimize their business analytics projects. As we journey through the realm of business analytics, where data-driven insights uncover hidden realities, models like K-means, regression, and SVM help us understand patterns and make decisions with aplomb. The confusion matrix reveals true positives and negatives, while accuracy ensures our predictions are effective. Precision focuses on the correctness of positive outcomes. Recall captures all true positives, eradicating doubts. The F1 score, a harmonic blend of precision and recall, balances the evaluation, leaving no room to stall. ROC curves guide us with true positive and false positive rates. AUC quantifies performance, helping us choose the best candidates. For regression problems, MSE calculates errors with precision. R squared measures predictability, a valuable decision. Cross-validation safeguards against overfitting's illusion, while underfitting reminds us of the need for a thorough fusion. Model evaluation empowers us to compare and select, to fine-tune our models and correct any defect. In the realm of business analytics, these techniques hold sway, guiding us towards insights and success every day. As the data unfolds and models come to life, business analytics thrives, cutting through the strife. With evaluation techniques, we navigate the path, ensuring our models bring success and avoid any aftermath. In the realm of business analytics, we strive for perfection, harnessing data's power with unwavering dedication. With models and evaluation, we unlock hidden doors. Guided by insights, we reach new heights and explore. Start planning your next global adventure with ease and convenience with our Booking.com referral link, https://www.booking.com/index.html. 8 = 7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our Anhub Metaverse channel, and please watch more interesting videos here.